Welcome back. This video is going to be a quick comparison video between a few structural patterns. More specifically, we're going to talk about bridge, adapter, decorator, proxy, and facade pattern. By the way, apologies for the band-aid. I was fine-tuning my moustache and then apparently I cut my nose. Sorry about that. But anyways, so let me repeat the patterns that we're talking about. First of all, we are talking about structural patterns. And which patterns are we talking about? We are going to talk about decorator, adapter, facade, proxy, and bridge. Now, if this is the first video you're watching in this playlist, be aware that there are already specific videos on each of these different patterns. So this video is just a comparison video, because what we're doing in this playlist is that we're going through all of the patterns in these books, all of the design patterns for object-oriented languages mentioned in these books. And if you're new to design patterns, I would highly recommend that you get this book, Head First Design Patterns. And if you're not necessarily new to design patterns, or if you're more like the reference kind of book person, I would recommend this book, Design Patterns, Elements of Reusable Object-Oriented Software. And to play it safe, just get both. If you're in an object-oriented language, makes total sense, good books. Links are in the description. But now, to these patterns. How are we going to approach this? I'm thinking we do it this way. How about we just look at the UML diagrams of all of these different patterns. I'll try to draw them all at the same time here on this whiteboard, just without text, sort of we just look at them visually, and then we try to think about what the differences are between these patterns. So let's get started. Let me remove this stuff. So let me make a plan. Let's draw decorator here, adapter here, then facade here, then proxy here, and then bridge here. All right, let's get going. First up, decorator pattern, and I'm using the diagram from the Head First book. So with a decorator, we've got an abstract component that is implemented by a concrete component, but also implemented by a decorator, which itself is an abstraction that has multiple concretions. So instead of drawing multiple ones, let me just do this sort of overlaying syntax to emphasize that you can have multiple ones of these. And these, in turn, have a decorator. So think back about what the decorator pattern was doing. The decorator pattern said that you had a particular thing, and then you could take decorators and wrap that particular thing. But you could stack any number of decorators, so you could decorate a decorated thing, or you could decorate a decorator that decorates a decorated thing, and so forth, right? It's like layers. So you have something at the core, which is this thing, and then you wrap decorators around that thing. So it's like a layered onion. You have this thing in the middle, and then you wrap decorators around that, one by one by one. And then when the computation happens, you go inwards towards the core, and then propagate the value outwards. Again, I'm not digging deeply into the patterns now, since there actually are specific videos on these patterns. So if you want to refresh your memory about these patterns, do go back to the other videos. But that's the decorator pattern. Let's now look at facade, also from the Head First book. Here's the class diagram. But the thing about the class diagram for facade pattern is that it's extremely simple. So the point with a facade is that you have a client, in other words, the user of the code, and this client uses some kind of facade. And this facade, in turn, is a facade over some complex logic, or some set of objects that are interacting in some complex manner, or I should say non-trivial manner. So literally this is the way they draw it in the book, and not necessarily with these particular interactions, but the gist of it is the same as in the Head First book. So the point is that here's the facade, right? This is the facade that introduces a level of indirection, and the facade is it's a facade over some complex behavior, some set of complex interactions. You have all of these different objects, and you want to avoid having to force the client to interact with all of this complex stuff. So instead you simply interact with the facade that interacts with all of this complex stuff. It's even borderline questionable whether this is really a design pattern, because there is no abstraction here in terms of interfaces or inheritance. There is no polymorphism here. It's just that you have some set of nasty things that you want to call, but instead of calling all of these things directly, you call your nice wall here in between, your facade. You make a single call to that facade, and then that facade makes all of these crazy complex calls. Let's move on. Let's look at the adapter pattern. So adapter pattern, also from this book, Head First. So in adapter pattern, you too have a client. Let me put C here to emphasize that it's the client. And the client has a target. And this target is implemented by an adapter. Let's put T here for target, A for adapter. An adapter, and this adapter has an adaptee. So I'm sorry, this turns out to be A and A, but I don't mean the same thing. This is the adapter and this is the adaptee. So remember, the point of the adapter pattern is that it converts an interface. The point of the adapter pattern is that the client wants to use some particular code using some particular interface. And this T here is the interface that it wants to use. It wants to use it in a particular way that it's always been using it. But for some reason, you need the client to use another object, which is the second A here. And this second object, the second A, this object here, doesn't follow the syntax of T, or doesn't follow the interface, doesn't correspond to the interface, doesn't respect the interface of T. It has a different interface. So C and A are incompatible. Think of it as they are incompatible puzzle pieces. They can't fit. So what you do is you stick this adapter in between. That makes, yeah, that was a super bad drawing of a puzzle piece, but I think you can see my point. You stick this adapter in between these two things to make them actually work. And the adapter here is this particular piece. So this particular piece says, I behave like the thing that you expect, but when you call me, I will delegate to this other particular thing that you actually want to interact with. And that's the adapter pattern. Let's move on. Sorry for moving super quickly, but we have a lot of ground to cover in this video, so I've really got to move fast. Now let's look at proxy pattern. So proxy pattern, again, from the Head First book. With the proxy pattern, you have a subject, that's an abstract class or an interface, and this abstract class or interface is implemented by two things, or has two concretions. And these two concretions are the real subject and the proxy. And then there's one arrow missing, and that's that the proxy has a real subject. So the proxy here says that there is an interface called a subject here. There is some kind of interface. So there is some set of families of things that you can interact with in some particular way, this particular subject. And then there's a concrete implementation, this real subject here. But then there's a proxy. And this proxy has been introduced to control access to this real subject. So when people want to interact with this real subject, instead of interacting with that real subject, what they will do is that they will interact with this proxy who will interact with the real subject. You can immediately see the difference here, that the adapter pattern, here we had two different interfaces. But with the proxy pattern, we have the same interface. The point with the adapter pattern is to adapt from one interface to a different interface, right? It's that translation. So it changes the interface, but it does not change the behavior. The proxy pattern, however, the point of the proxy pattern is somewhat to change behavior, but more specifically to control access to it. So the intent is not necessarily to change behavior, but the intent is to control access to the underlying thing. But definitely, the intent is to not change the interface. So the real subject and the proxy has the same interface. Sorry, I got carried away and got directly into the comparison. Let's now look at the bridge pattern. So the bridge pattern is sort of an appendix pattern in this book. So for the bridge pattern, we have to get to this book. Design patterns, elements of reusable object-oriented software. Let's look at the bridge pattern. Actually, let me move this bridge pattern header here and put it here instead to give me some more space, because we actually have a lot of space here. So with the bridge pattern, you have an abstraction and an implementor. So an abstraction that has an implementor. Let me put I here and A here. An abstraction that has an implementor. And then there is an implementation of this abstraction that they call the refined abstraction. And I think they use the term refined here to emphasize that this abstraction here is probably an abstract class rather than an interface. And then on the right side here, we have concrete implementations of this implementor. And again, I'll do sort of this 3D-ish notation, or like leaves on leaves notation, to emphasize that there can be multiple ones here. So you can have multiple concretions of this implementor abstraction. And actually, even though they didn't draw it explicitly in that diagram, I would say that it's a key part of the bridge pattern to actually realize that you can have multiple implementations of this abstraction. So we'll do this sort of leaves on leaves or a 3D notation here as well. And actually, let me just immediately refine this drawing of the bridge pattern. Let me remove the letters, and let's simply just think about this as A1, A2, and C1 and C2. Point being that you have abstraction 1 and abstraction 2, and then you have a concretion 1 of abstraction 1 and concretion 2 of abstraction 2. So, or maybe that was an unhelpful way to think about it. Maybe what I should have done is that I should have said the hierarchy of A's and the hierarchy of B's, or something like that. So actually, maybe that makes more sense. So let's think about this as the hierarchy of A. Let's think about this as the hierarchy of B. and then let's think about the first one on top of this stack of leaves is as A1, and the first one here on top of this stack as B1. So here are a number of different A's and here are a number of different B's. And A's have B's because of this Haza arrow. And that's the bridge pattern. So let me add some dividers here and then let's start to do some comparisons. Alright, but before we move any further, let's also add some letters to the decorator pattern picture here because we have letters in all of the other patterns. So in the decorator pattern, this was a component, so let's write C here. And then we had a concrete component, let me add CC. So sorry, these letters are just totally informal, just so that we can have some kind of a reminder of what that thing actually was. So we have the component, the concrete component, and then the other implementation of the component is the decorator. So let's say D, and here we can have multiple implementations of a decorator. In other words, we can have multiple decorators in the decorator pattern. So let me just put CD here to denote concrete decorator. So these are concrete decorators. But now let's talk about the differences. Let's start by reading the definition for all of the different patterns one by one. We start with the decorator pattern. So the definition from the headfirst book of the decorator pattern is that the decorator pattern attaches additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending a functionality. So the point of the decorator pattern is, in other words, to say that instead of creating another subclass of a particular thing in order to change behavior of how some method of that thing behaves, we instead achieve that behavioral change through composition rather than through inheritance. More explicitly, through wrapping a decorator around a particular thing. Within the context of this pattern, that means these decorators that can be treated uniformly because they share this decorator interface are wrapped around a concrete component. And the decorators, since any decorator is a component, any decorator cannot just wrap a concrete component, but it can also wrap any other decorator. So again, sorry, I'm kind of glancing over the details since there are specific videos on these different patterns. So if you haven't watched those videos and you want to know more about the pattern, do check out those specific videos. So that's the decorator pattern. Then, adapter pattern. The definition of the adapter pattern, also from this book headfirst, is the adapter pattern converts the interface of a class into another interface that the client expects. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces. And this whole notion of incompatible interfaces is really the key point of the adapter pattern. Just like a physical adapter, like a physical plug that you use to adapt from one country's plug to another country's plug, for example, or from literally from one kind of interface to another kind of interface. Just think about how you're adapting cables, for example. I just saw this laying around, and this is actually a perfect example. Even this you could consider as an adapter. I mean, it converts from, I guess, mini DisplayPort to DisplayPort, or perhaps in the other direction, depending on how you think about it. So if you think about it then, it becomes obvious how decorators and adapters are different, because the intention of a decorator is that you want to change behavior, whereas an adapter, you don't care about behavior. Behavior is not the point. The point is that you want to use one interface, but the thing you want to use happens to have a different interface. So you stick an adapter in between so that you can use the thing that you want to use that has a different interface, but through your own interface. So hopefully those two are clear. Adapter focuses on adapting an interface. Decorator focuses on extending behavior by wrapping the thing that you want to change the behavior of a potentially infinite number of times. Let's move on to the next. Facade. Let's look at the definition of facade. So here's the definition of the facade pattern, again from the headfirst book. The facade pattern provides a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use. So think about it in terms of this picture. The client wants to use some very complex subsystem, but instead of using that complex subsystem directly, the facade provides a higher level interface that the client can interact with instead, and this higher level interface instead interacts with this subsystem. So the facade doesn't really necessarily wrap something in the same sense as the adapter, because I mean, if you think about these two, they do kind of similar things, because the adapter adapts from one interface to another, and in some sense the facade does too adapt from one interface to another, but the facade also has an additional responsibility, which is simplification. The intention of the facade is to simplify this complex subsystem, whereas the job of the adapter is simply to adapt from one interface to another. So this is why we're drawing all of this complex stuff here. So the facade probably wraps something which is unnecessarily complicated, or complicated to the extent where you don't want to interact with that directly. I like to think of this as that this might be a third-party library or something like this that you want to use and you don't necessarily have control over, so you can't refactor, for example. But it could also just be that you have a highly decoupled system. You have a system that you've built in a highly decoupled manner, which is a good thing. Like you've managed to identify reusable small pieces that you can extract and then compose together in various ways. But in order to do any meaningful work, you perhaps have to compose, you have to bring together a bunch of different pieces and use them in kind of intricate ways. And so maybe the facade you use to simplify some of that. So you have all of these super decoupled pieces that you can use in very powerful ways. You have those, you have the power of that, but you still want to give yourself a simpler interface so that you sometimes don't have to deal with all of that when you want to do some particular task that you repeatedly do, or that you, for example, want to give a particular name. So that could potentially be a good use case for the facade pattern. And again, that is too complex to be an adapter. It's not an adapter because it's not simply adapting from one interface to another. There's more logic involved there. Also, of course, if we look at the UML, it's different. I mean, here in the facade pattern, notice that this is not an is-a arrow. It's not an implements arrow. And it's not necessarily a has-a arrow either. We're just stating that it somehow interacts with this complex subsystem. Whereas in the adapter pattern, this adapter here actually is a target, or implements the same interface as the target. So the adapter behaves as the target. Before we go further, let me just pause here for a second. I should have said before that, I mean, interestingly, if you think about the way these pictures look, let me move out of the frame. Think about these different diagrams. Actually, they are different. I didn't really think about that as we went through the different videos, but it's not just that they differ in intent, which is super important, but they actually also differ structurally. Like, notice how we haven't really given proper names to them, but still, structurally, they are different. I mean, bridge is obviously not the same as adapter. Adapter is obviously not the same as proxy. Proxy is obviously not the same as facade, and so forth and so forth. They are actually different. And if you think about, which is kind of what we're doing here, if you think about carefully what they actually do, you realize that they are specialized for very different scenarios. They're very good at solving specific problems that have, and this is when we get back to intent, that have different reasons for appearing. They're actually solving problems that are qualitatively different. But anyways, that's a quick side note. Let's now actually move forward. Next pattern. So we've talked about decorator, adapter, and facade. Let's now talk about proxy. So the definition of proxy pattern, again, from the Head First book, is the proxy pattern provides a surrogate or placeholder for another object to control access to it. Or if I'm even more specific, provides a surrogate or placeholder for another object in order to control access to it. Think about it in terms of this picture. The proxy pattern provides a surrogate or a placeholder. This is the placeholder for another object to control access to it. And the other object is this object. And the intention is to control access to it. So, a client, instead of using this particular real subject, it uses the proxy, which determines when or if to delegate to the real subject. And of course, importantly, the reason that we have this subject interface or abstract class is that the real subject and the proxy needs to share some kind of common ancestry. They need to share some common ancestor so that they have a similar interface, so that they can be treated interchangeably, or so that we can interchange a real subject for a proxy or a proxy for a real subject. So in other words, in order for a proxy to be able to stand in place of a real subject, it needs to have the same interface as the real subject. So if you think about it, the proxy is almost like the inverse of the adapter pattern, in the sense that the adapter changes the interface but not the implementation, while the proxy changes the implementation but not the interface. But this is not entirely true, or rather the world is not that simple, because you could also say the same thing we said about proxy, we could also say about decorator, because decorator too does not change the interface but does change the implementation. So what is the difference then between a proxy and a decorator? Well, I interpret it this way. Here I think we get into the discussion of the intent rather than the structure of the pattern. Because if you read these books, it seems that they're saying that you can have proxies that are treated as wrappers that can wrap wrappers in the same sense as decorators. I mean, decorators are sort of like the shells or the layers of an onion. You can decorate a decorator that decorates a decorator, etc. until you get into some core. And you could sort of do the same thing with proxies, where you have proxies that proxies a proxy, and where you have a proxy that proxies some proxy that proxies some proxy that in turn proxies some real subject. My understanding from reading these two books is that that's not necessarily the common use case for a proxy pattern. The common use case for proxy pattern is simply that you have a single thing that you want to proxy, that you want to control access to. While with the decorator pattern, that's actually what you're looking for. You're actually looking for this composability. You're looking for, if you watched the last video, we talked a bit about combinatorics, like what happens when you have many combinations of different things and then you have a class explosion of different specializations that you have to implement as classes. Decorator solves that kind of problem where you want to be able to say, let's say that we have CD1, CD2, CD3 here. So to represent that, let me just put 1 and 2 and 3 here. And the problem we're solving with the decorator pattern is when we want to be able to treat all of the different combinations of these different classes as a special case that has some special implementation. And formally, I think this is called the number of k combinations for all k. So if you have the set of 1, 2, 3, sorry, I should have written it like this. If you have the set of 1, 2, and 3. So when we talk about combinations as opposed to permutations, order doesn't matter. So when we say something like the number of k combinations of this set, we mean the number of ways that we can take k elements from this set without caring about the order in which we extract the elements. So if k is 3, in other words, we're looking for 3 elements out of this set, that means we only have one combination. There is only one way to take that. I mean, it doesn't matter if we do 1, 2, 3 or 3, 2, 1, it's still the same set because order doesn't matter. So for K3 there's just one. But decorator pattern is not interested in that problem. Decorator pattern is interested in the number of K combinations for all K. So when we say for all K, we mean for K equals 1 and K equals 2 and K equals 3. And if we talk about 2, for example, then we have more ways of combining this because then we take 2 elements. So then we have 1 and 2 and we have 2 and 3, and we have 1 and 3. So we have 3 ways of doing that. And then for K1, we have 1, and we have 2, and we have 3. In other words, we just take out one element. And then, again, like in the beginning we said, we have also 1, 2, 3. So the number of K combinations for all K for this set, sorry for going a bit quickly, but this is sort of tangential to what we're looking at. The number of K combinations for all K for this set would be this set of 1, 2, 3, 4, 5, 6, 7 elements. And actually I said that the answer here would be 7, but formally the answer would actually be 8 because the empty set also counts as a possibility. Just to be like mathematically accurate, I just want to say that the answer here then actually is 8 and not 7 because in this set of sets, the empty set also counts as one of the answers, but tangential. So the reason I wanted to say this is that I'm saying that if you have 3 things, 3 behaviors, combining these in many different ways, where sometimes you can have only this behavior, sometimes you have these, sometimes you have these, sometimes you have all of these, sometimes you have only, etc., etc. There are many different combinations. So quickly you can reach a class explosion. What's worse is that now we talked about combinations. If you talk about permutations, where order actually matters, where 1 and 2 is different from 2 and 1, think about it this way. If one of the behaviors is increase the price by adding 10, and the other behavior is double the price, then it matters whether you first add 10 and then double, or double first and then add 10. So in that scenario, we're actually talking about the permutations, and then the number of different permutations essentially that we would have is a lot more. So, sorry, now I'm getting really off track. Let me remove this stuff. Here's what I'm trying to say. Decorator pattern is explicitly trying to solve that problem, or specifically trying to solve that problem. It's trying to solve the problem where you want to decouple different behaviors so that you can compose them in any way you like. That's the problem that decorator pattern is trying to solve. That's a different problem from what proxy is trying to solve, because proxy is trying to say, for some reason you need to control access to this underlying thing, so let me just stick this thing in between. So in some ways, I would say that the proxy is kind of a simpler problem. It's an access mechanism. It's like we're saying, here's something that I need to be careful about interacting with. So just to make sure that I won't do it incorrectly, let me stick this proxy in between and interact with a proxy instead. Kind of. But yeah, I mean, if you would implement a proxy as that a proxy that can proxy a proxy that can proxy a proxy, etc., you would probably make the proxy diagram look a lot like the decorator diagram, if not exactly like the decorator diagram. So here I think the main point is that intent is different. Let's now talk about the final pattern, bridge pattern. The definition of a bridge pattern we'll get from this book, Design Patterns, Elements of Reusable Object-Oriented Software. The intent of the bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. And if you've seen my video on bridge pattern, you know I kind of think that definition is a bit strange. And the way I like to think about bridge pattern is this way. I like to think of it this way. We have two inheritance hierarchies, or two polymorphic hierarchies, and we want them to be able to vary independently. So we want to be able to take anything of type A and combine it with anything of type B. Notice how this problem is very similar to what we talked about now with the decorator problem. But with the decorator, we had one set, sorry for drawing here in the adapter area, I now mean that what we're talking about here has to do with the decorator. We have one set of some number of things, 1, 2, 3, etc. And we want to be able to combine these different things in different ways from a single set. Whereas with bridge pattern, it's slightly different because here we have, let's use the terminology from here, let's say A1 and A2, one set, and then the second set, we have B1 and B2. Here we had three, like B1 and B2 and B3, but in order to reduce the complexity, let's just think about two elements in each of the different sets. So we have the set of A's and we have the set of B's. And the point is that we want to be able to combine anything from set A with anything from set B. So it's like you have this problem where you have, let's think about it this way, you have two things that you want to be able to do. And you have multiple ways of doing the first thing, and you have multiple ways of doing the second thing. And then you want to be able to combine any two of the many combinations of ways of doing these two things. And that's why we have one hierarchy here and one hierarchy here. So let's think about this in relation to the decorator. I mean, what the decorator does is that it changes the implementation of a single thing. But the bridge, then we have two ways of doing things. I mean, of course, in the decorator, here we have a concrete component, but of course, we could have multiple concretions of a component, which means that you can have multiple different components and multiple different decorators, which actually also means that we have two sets where you can combine any piece from the two sets. And in fact, you can actually have multiple decorators on the decorator end. But the difference here is that the concrete component and the decorator both implement the same interface. They are both components, right? Think about it. Concrete decorators are decorators and decorators are components. And the concrete component is also a component. So that means that everything here in this pattern, everything shares the same interface. But in the bridge pattern, it's different. We don't share the same interface because here we have hierarchy A, one interface, and hierarchy B, potentially a completely different interface. And this is probably why we call it a bridge. It's like bridging over to a different interface. So the bridge pattern is actually a really flexible way of architecturing your application. So again, we're solving different problems. I mean, yes, these are even structurally different. Like if you look at the structure of these images, they are different. But they are also different in the kind of problem that they're solving. I mean, bridge pattern is a structural pattern, and strategy pattern, for example, is not a structural pattern. Strategy pattern is a behavioral pattern, but I actually think that bridge pattern is a lot like strategy pattern, and we had some discussions about that in the comments, like strategy pattern plus adapter pattern or something along these lines. Because if you think about strategy pattern is all about dependency injection. It's all about saying, I have this thing that I want to do, but I don't want to care about how that thing is performed. So I will just declare that I will accept something of a particular interface, and then you pass me a concretion that corresponds to that interface, and I will call the methods of that interface whenever I need it. So I have a method, and my method accepts an argument of some particular type. So you dependency inject that thing into me, and then I can call methods on that thing. And that's, I mean, kind of the same thing here. It's like we have A's, and A's expect a B, right? You dependency inject something of type B into A's. But the key portion here is that we have, as opposed to strategy pattern, we have two different hierarchies. In other words, actually, let's just draw the strategy pattern. Sorry for breaking the rules of going outside of structural patterns and into behavioral patterns. So strategy pattern, drawn from this book, looks roughly like this. You have a, let me remove this stuff. You have a context, let's call it C, that uses some strategy, let's say S, that can have any number of implementations, let's say S1. And then we'll use this sort of leaf-on-leaf notation to denote that there can be multiple different implementations. So if you think about it, this is like half the bridge. What's missing, let me actually, before we go further, you just draw a red line here and then state that this is strategy. So again, this is like half the bridge. It's like all of the bridge except for these A's. So to make this the bridge pattern, we would simply have to add this implementations arrow and the different implementations that the context could have, the different implementations of the context that we have. But let me remove that for now. So if you think about it, the bridge is almost kind of like a generalization informally. It's like taking strategy a step further. It's like saying, actually, this is a really good idea, but what if the thing that uses the strategy also is abstract and also can have a number of different implementations? Which again makes a lot of sense because it's very flexible. And actually, I mean, if you think about the statement, program to abstractions rather than concretions. In other words, avoid programming or coupling classes to classes. In other words, instead of coupling to concretions, instead of coupling to classes, couple to interfaces. Because if you always couple to interfaces, you'll naturally end up in this kind of scenario. Maybe the whole dependency injection thing would perhaps require a bit of thinking before you actually end up in that scenario. But probably, I mean, if you start to always program to in interfaces rather than implementations and really think about how you're doing it, you'll probably end up in bridge pattern kind of naturally, like it's sort of a natural extension. And by the way, this is maybe a good time to run in the statement where that I think somebody said that programming was discovered rather than invented. Sorry, I can't remember who actually said that, but I just think that statement is kind of profound. It's like, it's kind of like logic. Like, if you think about it long enough, you'll discover these things that are inherent conclusions or natural conclusions from the first principles or from the axioms that we decide upon. So like, if you decide upon the axioms of object-oriented programming, if you decide that, okay, these are the building blocks that I have in object-oriented programming, it's kind of a natural conclusion to end up with things like bridge pattern because it's a very flexible way of thinking about it. It's a way of actually being able to build small pieces that you can reuse. So this whole notion or this idea of the panacea where we would have different things that we compose together where these small things are really reusable so that we don't have to rewrite them. Like in object-oriented programming, the way to get to that kind of flexibility is through things such as the bridge pattern or in some sense dependency injection into madness. Right? Okay, that's way too much of an aside. Let's wrap that up. So I hope this overview kind of makes sense. Let me just quickly say again. The decorator pattern extends behavior by decorating a component. The strategy pattern we threw in here even though it didn't belong because what we were talking about were structural patterns. But let's then just state also that the intent of the strategy pattern is to define a set of algorithms or a family of algorithms where you can exchange one of the algorithms for the other. You can vary the algorithms independently from the context of the thing that uses the algorithm. Next one, adapter pattern. Adapter pattern adapts from one interface to another interface. You want to use a particular interface, but the thing that you want to use has a different interface. You stick an adapter in between so that you can use the thing you want to use. The proxy controls access, while the adapter says, I only change the interface, I don't want to change the implementation. The proxy says, I change the implementation, but I don't want to change the interface. So the proxy's a thing, but uses the same interface. So you can place the proxy instead of the thing that you wanted to use because it has the same interface, it's interchangeable. But then the proxy controls access to that thing that you placed it in front of. The facade is super simple. I mean, the facade has none of this dependency injection or none of that stuff. The facade is a term that we use simply when you have a scenario where you have some complex subsystem and then you throw a facade in between. You say, here's the wall. Use this simpler thing, and this simpler thing will interact with all of that complexity directly from the subsystem. And again, this is not the same as proxy because it doesn't necessarily require the facade to have the same interface as anything in the subsystem. And it's not the same as the adapter because it doesn't necessarily adapt from one interface to another. I mean, the facade has a single interface, but the subsystem might have a bazillion interfaces. So it's simply a way of hiding some complexity of some subsystem. The bridge pattern is perhaps actually most easily thought of as an extension of the strategy pattern. It's like the strategy pattern, but where the context that uses the strategy also is an inheritance hierarchy, or also is a polymorphic hierarchy. So you have two inheritance hierarchies, or two polymorphic hierarchies, and one of the hierarchies uses things from the other hierarchy. So you can take anything from the first hierarchy and pair it up with anything from the second hierarchy, and that's a valid pair. So in some sense, it's a way of avoiding duplication of code and increasing reusability. Okay, so as usual, I thought this video would be super short, but then it turned out not to be. I'm sorry about that. I hope this makes sense. If you appreciate this kind of comparison video, let me know in the comments, and perhaps we'll do more after we've dug through these patterns, but only if you actually think they're useful. If it's just too much repetition, let me know and we won't do them. I don't really know which pattern is the next pattern, in other words, for the next video, but there are lots of patterns left, so remember to subscribe so that you won't miss the upcoming pattern and the upcoming videos. Before you go, give it a thought. You might want to get this book, or you might want to get this book. If you're learning object-oriented programming, if you're working with object-oriented programming, super good books to have. As you can see, people have been thinking a lot about these things. And if you dig down, there are actually a lot of interesting thoughts that have been thought, I guess. Anyways, beyond that, I've actually started this side project where I'll try to write my own book on design patterns. So if you think that sounds interesting, be sure to check out the link in the description. Thank you super much for watching. Remember to subscribe, and I'll see you in the next one.